Hi, and welcome to the very first video of 2021. Feels so weird to be saying that for some reason. If you're a patron on Patreon, then first off, thank you so much for your support, you are amazing, and secondly, you may have already seen this. For everybody, this is a very easily customizable 3D wooden star with pure CSS shading. And by easily customizable, I mean only changing the number of points n or the pointiness factor f, which is a number between 0 and 1, and the smaller it is, the pointier our star is. So only changing one of these two values, or both, completely alters the look of our star, and we don't need to modify anything else in the code. So as you can see right here, we have two opposing star-shaped faces, and in between them, for every arm of the star, we have two lateral sides. So there's one lateral side before the arm and another one after the arm. And this wording is probably also giving you a clue about the structure. We'll be having one element per arm, and we'll be creating those lateral sides using the before and after pseudo elements. And similarly, we'll be using before and after pseudo elements on another main component to create those star-shaped faces. So let's move on to the code. We already have the number of points n and the pointiness factor f, and now we'll be creating the star wrapper. And as I mentioned in the previous video, we cannot have just dot emoji. We need to put this here, class equals. So yeah, not my favorite way of doing things, but I'll survive. Now, within this wrapper, we'll be having a loop and generate those star arms. So for let I going from 0 all the way up to n, increment this I at every step, create our arm components. Okay, and outside the loop, we'll have a main component. Okay, and now let's switch the CSS and put something on the screen because white isn't too exciting. And as I said earlier, we'll be using the before, not be fire. Well, you can be fire if you want. The fire of hell. You can be anything you want. Actually, that's a lie. With good marketing, but still a lie. So here we'll be having content, nothing, because we won't be seeing anything without that set. And also a background, because even if we have something, we won't be seeing it without a background. And then we'll be taking this with copy paste, because copy paste makes the world go round. Okay, and here we'll be setting some dimensions. What we want is a 0 by 0 content box, and around that a padding, but let me show you that here. So here in the middle we have a 0 by 0 content box, which is essentially just a point, the origin point, and then the padding is essentially going to be the radius of the circle on which the points of our star are situated. So yeah, and yes, this is a pentagram, but we won't be summoning Satan today. There's no black cat present. It would be just wrong without a black cat. So here we'll be having a padding and equal to that outer radius, because as you saw there were two circles there and we're taking the radius of the outer one. So let's say this is going to be something like 9 ems, and since we're here anyway, let's also set the width or thickness of our star. Let's say it's going to be something like 2 ems. Okay, so having done this, we're still not seeing anything, and we're not seeing anything because by default pseudo elements are inline and this is not going to do anything. So let's do something in terms of layout, and it's going to be very similar to what we've had in other previous demos. So I'm using pretty much the same basics for layout and things like that. So it's going to be display grid on the body and all div elements. And here we'll be having, on the components, we'll be having place self, center, and then for all div elements and all pseudo elements before and after, we'll be having grid area, the one cell at the intersection between the first row and first column. So basically that's all we have. One single cell, one row, one column, one cell. That's all we have. And let's put this in the middle vertically as well. So on the body, we'll be setting height equal to the full viewport height. And of course, get rid of the scroll bar, margin 0. Let's also give it a background. So this is a color I used at one point recently and I liked it, so I started using it pretty much everywhere. One more thing we need to set on the body, and that's going to be a perspective, and this is going to make everything that's further away from us in the back appear smaller, and everything that's closer to us to the front appear bigger. So yeah, that's what perspective does. And something else we want to set on all div elements before I forget, transform style preserve 3D, and this is going to allow us to have elements that are transformed in 3D and also have 3D transformed children, because otherwise the default for this property is flat, and the 3D transformed children will get flattened into the plane of their parent. Yeah, that's the thing with it. And now the next step would be to make this look a bit 3D, right? Make it spin in 3D. Yeah. So we'll be taking this emoji from here, copy pasting it. As I said, copy paste makes the world go round. And we'll have a rotate around the y-axis. So keyframes rotate y, right, and this is going to go to transform rotate y 1 turn, right, and we'll be using an animation duration right here. So you will have animation rotate y, that animation duration linear infinite, and yeah, this should do it right now. Let's also add an overflow hidden just in case. Okay, fixed the scroll bar. Okay, so now that we've done this, let's also set a J, and this is going to be like a switch, and I will link to the switch technique article in the description. So here we'll be having this switch to 0, and then on the after we'll be switching it to 1. So J is going to be 1. So here we'll be computing a sine of J. This is going to be calc 2 times J minus 1. So here we'll have transform rotate y calc sine of J times 90 degrees, and then we'll have translate along the third axis by half that thickness, and we should be seeing something. Okay, that looks a bit difficult to see because they both have the same color, so let's do something like filter. We'll remove this later, but for now calc J times 180 degrees, something like this. This should do it. Okay, much better. Now let's also take this right here. Let's make this is going to be the arm components, right? And let's make this an HSL 25, 50%, 50%. We'll be tweaking this later. We won't be needing that content, right? We'll be setting the width to that width, and the height we'll be setting it later, but for now we'll just set it to that outer radius, right? Oh, right. Don't let me anywhere near a keyboard. Okay, we're seeing it somewhere in the middle, right? Okay, but we wanted its top to start from the very middle and go down from there. So we'll be setting the height of the arm to 0, and this should do it. Okay, that's good. Now, having done this, let's move up here, and let's create that star shape. So what we'll want is an array of vertex coordinates. So this is going to be empty initially, obviously, and we'll be computing a few things like a base angle, and let me show you how we compute that. So this is a 5-point star, but when you look at the polygon points that we need to create it, you notice that we have twice as many points. So we have these star points, and we also have these vertices here on this smaller circle. So basically we have a vertex on the big circle, a vertex on the small circle, big circle, small circle, and so on. And they keep alternating, right? Now, all these angles are going to be equal, right? This angle is going to be equal to this angle, and they're all going to be equal to 360 over twice the number of points. So 360 over 2n, or 2 pi over 2n, which is essentially pi over n, right? So now that we know that, we can also compute the cosine of this angle, right? So let's do that. Let's put it into code, and we'll then take it from there. So we'll have pi over n, the base angle. Then we'll have cosine, which, what a surprise, is going to be the cosine of this base angle. Right? And then let's move on. We'll need to compute the radius of this small circle. And this is where the pointiness factor comes in, because it's going to be that factor times the distance up to the intersection with this segment. So we're going to have the intersection with the segment somewhere there, and this segment is going to be perpendicular onto this radius. So we'll have a right angle there, so we'll have a right triangle, right? So the length of this edge right here in this right triangle is going to be the hypotenuse, this, times the cosine, right? And we've already established that the relative value of this is going to be 1. So the relative value of this edge is going to be equal to the cosine. So the inner radius, the relative inner radius, is going to be f times the cosine. So here we'll be having, a relative radius inner is the pointiness factor times the cosine, right? So next we'll have a loop, and here we'll generate the vertices, and of course this is going to go up to 2n, because as I said, we have 2n vertices. And here we'll be having the current angle. This is going to be I times the base angle. And let me show you something else. Here we start from 3 o'clock. If we want to start from 12 o'clock, we need to go back by 90 degrees, because the positive direction is the clockwise one, and going this way is the opposite direction. So by minus 90 degrees, or minus pi over 2, right? So we're going to need to subtract half of pi. And next we'll have the current radius, which is going to depend on the parity, right? So once it's going to be on the outer circle, on the big circle, and once on the small circle. So it's either going to be one or the other. Okay, next we're going to push to the array of vertices the new set of coordinates. And in percentages, everything is going to be relative to this midpoint. And in percentages, this midpoint is the 50%, 50% of our element. So basically, we're going to have 50% plus 50% those relative values, which is 1 for the big radius, for the radius of the big circle, and relative radius inner for the other one. So always the current radius, right? Times the cosine for the horizontal coordinate and the sine for the vertical one. So basically, that's going to be 50 plus 50 times the current radius times cosine of the current angle. And of course, we can take this 50 and we can take it out in front, right? And we're going to have 50 times. Okay, and then something very similar for the other coordinate except this is going to be sine. And now let's do a bit of a cosmetic. So map this, and for every pair of coordinates we'll map this every pair of coordinates, and we'll take every coordinate and turn it into a percentage value. And of course we need to interpolate that. And then join this with a space. And now here in a style attribute, we can of course set this as a custom property. And now we can switch to the CSS, and here set clip path polygon and use that list of coordinates. And you can see it now, right? So now if we change this to, let's say, 6, okay, or we can have 0.25, right? It's going to be pointier. We can have 85, and we can have 9 here, right? Something like this. So yeah, it basically depends on what we want. We can have whatever we want there. Now let's move on to the arm component, and here we'll have, well, actually first off we'll set some transforms on arm. So transform rotate X, and this is going to be calc. Of course we'll be needing to set a few more custom properties here. So here we'll be setting the number of points, right? And very similarly here we'll be setting the arm index in a style attribute, of course. So this is going to be the arm index equal to the loop index, and of course here we'll be computing like a sort of a progress. So this is going to be calc I over n, and having done this we'll have that progress times 1 full turn, right? And then we'll have translate along the y-axis by minus the outer radius. So let's do that. Okay, it's starting to look like something. Now here we'll want these two sides which are overlapping there, right? We'll want them to get transformed with respect to that top edge, right? So we'll have the transform origin at 0 vertically. So transform origin 50% 0. Okay, and then we'll have here we'll have a case switch which is going to be 0 initially, and then on the after we'll have this switching to 1, right? And then we'll be computing a sine of k. So sine of k, very similarly to the sine of j, and here transform rotate y. This is going to be k times half a turn, or 180 degrees, same thing. And then we'll have rotate x, and let's say it's going to be 14 degrees or something bigger. Surprisingly, it's kind of like fitting, but that's just an accident. And as you can see, those overlap. Let's make it bigger so you can see it better. as you can see, those edges intersect and they're like too long. So we're going to need to change the value of this height. We'll need to compute it properly, and we're going to need to compute properly the angle of this rotation. Now we're going to go back here and we're going to compute that stuff. So let me show you what we need to compute. This is basically going to be the height that we need, the length of this edge right here, and we're going to get it using the law of cosines. So the law of cosines says that we can get the square of an edge if we know the other two edges and the angle between them. So the square of one edge is going to be the sum of the squares of the other two edges minus twice the product times the cosine between them. So here, basically, this edge squared is going to be this one squared plus this one squared minus the product between this one and the cosine, twice the product, minus twice the product. Okay, so let's put this into code right here. So our relative edge, actually the square of it, so the square is going to be 1 squared is going to be 1, so that's the outer radius, the relative outer radius. And then we have, yeah, don't let me anywhere near a keyboard, power relative radius inner raised to the power of 2 minus twice relative radius inner times the cosine, and the relative edge is going to be the square root of that value. Okay, so now we know that. Okay, so knowing this, the relative edge is okay. So now we can use it right here. We're going to need to interpolate this and multiply it with the relative volume. Okay. And now we also need to compute this angle right here. And we're going to get it also from the law of cosines, because we know the edges next to it and we know the opposing edge. So that means that we can get the angle from here, right? So it's going to be the sum of the squares of the edges next to it minus the square of the edge opposing it over twice the product of the edges next to it, right? So let's get here and so the relative actually it's not going to be a relative. I mean, we're going to want its relative value, but yeah, here we're just going to have the radian volume. So this is going to be the r cosine of 1 plus the square minus this squared, right? So all of this is going to be over the relative edge times 0.5. Okay, so this is going to be the radian value, and we can compute the degree value, and this is going to be the radian value times 180 over pi. Okay, so now we'll be taking this and we'll have degree, right? So here, instead of 19, we'll have that custom property, that degree value. Okay, so this gives us the star shape. We're getting closer, right? It's starting to look better. And now we can also get rid of that filter. because we don't need to differentiate between stuff. Now, the next step would be to make those faces, the faces that are higher up, to make them lighter, and the ones that are further down to make them darker, right? So we can do something like this right here. So here we can compute an absolute value, and this is going to be max between calc p minus 0.5 and calc of 0.5 minus p. So one of them is going to be positive and the other one is going to be negative, and maximum is always going to pick the bigger one, which is always the positive one. So that's the deal there. And we want a relative incline, which is going to be twice calc twice that absolute value minus 0.5. Okay, and now here we can have 50% times 1 plus that relative incline, and of course we have to put everything within a calc, because otherwise that's not right. Okay, and now as you can see, the top ones are lighter and the bottom ones are darker, right? Okay, so now that we've done this, but this isn't quite right, because you see those, if you assume that the light is coming from above, those are that look down are actually lighter than those, and that's a bit weird, and those are lighter than those who are basically facing up. So that's a bit weird. But if we have Houdini support, we can actually compute a smarter kind of shading. And if we don't, well, we'll be stuck with this one, which is better than nothing still. So yeah, and let me show you how we detect Houdini support. So let's say that on the body, right, we'll be having a support custom property, and this is going to be Houdini and 0 by default, so not supported by default. And here we're going to register property Houdini, and we're going to have syntax initial value 1. So if this is supported, we're going to get 1 inherits true, right? So having done this, right, let me actually show you something right here. So let's say it's going to be HSL times calc S times 180, 150%, right? And let's say now that Houdini is not supported, that thing doesn't work. Okay, so you see we get a different result, whether depending on whether that custom property is registered or not. And if Houdini is not supported, that custom property is not going to get registered, right? So that's kind of what we're doing here, except we'll be using it for the shading, not for the body background. So here we'll also have not supported, which is going to be calc 1 minus that support flag or support switch, whatever you want to call it. Okay, so having done that part, we need to compute one more thing, and that is, actually, let me show you something. What we actually want to compute is the angle between the normal to those side faces. So the normal to those side faces and the horizontal plane. So just imagine that we draw a perpendicular from the center of the star onto the plane of those side faces, right? Those lateral faces. And we want the angle of that normal with the horizontal. That's what we want. And let me show you here. If you consider that this is the middle section of our star, then that normal is going to, for this one right here, right? That normal is going to be this one right here. It's going to fall outside of it. So you see this one, this segment is from here to here, but the perpendicular is going to come somewhere here, right? It's going to be outside of it. And what we want is the angle of it. Well, let's rotate. Assume we rotate the screen a bit, and everything is rotated by 90 degrees, and this is actually pointing up to the vertical, and this is the horizontal. We actually want this angle right here. Okay, so we can get this angle by knowing this angle right here, this angle, and knowing this angle right here, right? Because we can get it from those two angles. But what we'll actually use is the relative value of this angle with respect to a full circle. So we're going to divide it by 2 pi. And we'll actually take the complementary of this. The complementary of this angle. So which is going to be this one. So the complementary of this angle in this right triangle is going to be this angle right here. And this is going to give us this other angle, which is weird, but yeah. So let's compute that relative complementary. And this is going to be, actually we can just do 90 minus the degree value and everything over 360, because it's exactly the same thing whether we use the radian or the degree. Yeah, it's pretty much the same. It doesn't matter. So okay, I messed up something there. No worries, I'll be fixing it. Okay, so now doing that, we'll be computing a few more things right here. So we'll have a sum, and this sum is going to be so we have the angle, right? The angle of this point, right? Oh. And then we're going to need to add or subtract to get the angle for each of these, right? Add or subtract. Add or subtract this angle, the complementary. So, and that's going to depend on the sign of k, whether we add or subtract. So we're going to have p plus the sign of k and we're going to want to add 1 so that when p is 0 and we subtract something, we don't get under 0. Right? And then we're also going to want, this is why we'll need Houdini. We're going to want to have a floored value. So this is going to be calc the sum minus 0.5. So basically this is going to be floor of the sum. So we register, so property, and this is how we force that int value to an integer. We register it as an integer. So syntax, initial value, and then we also have inherits, which we can set to false, because this is set on these pseudo elements and we don't have any children of those, so we can just set it to false, and that should probably be better for performance, right? And then we're going to have modulo, and this is going to be calc sum minus the integer, which is basically the floor of sum, and next we're going to have a term, and this is going to depend on whether Houdini is supported or not. So if Houdini is supported, we're going to use that modulo value. So if we have support, we're going to use that modulo value. And if we don't have support, we are going to use just p. Right? So here we're just going to replace p with the term. And this should give us much nicer shading. You see, this one that's facing down is darker than this one that's facing up. And this one is lighter than these ones that are more vertical. So you see, it's basically, if it's facing up, it's the lightest. And as it goes down, and so it's horizontal and facing up, it's the lightest. As it goes down and becomes vertical, it just gets progressively darker. And then it rotates and it starts pointing downwards, it gets even darker. And when it gets to be horizontal and facing down, it's the darkest. That's basically the whole thing. Now here, I think we can do something like, let's do, okay, we're going to take this URL, right, and use background blend mode, overlay, should do something like that. Let's make this background color, just background. Okay. Okay. It's starting to look like something. One more thing we'd like here, so another overlay, and this is going to be initially nothing. So unquote, just a space, right? And here for the main, let's say our over is going to be a linear gradient, RGBA, so let's make it darker as it goes down. Let's see how that works. Oh, of course, it also needs a comma. Oh, come on. That should have worked. So I have no idea why it doesn't work. Let's see. Oh, okay, I got it. Of course, I should have interpolated this. Because it's a custom property. Yep, makes sense. Makes perfect sense. Let's make this 0.5. Oh, come on. And yeah, it does look darker, but that's, yeah, I can actually use black there. I mean, it does look lighter. I think we can actually use, let's see what happens if we use, no. White. That's probably going to mess it up. Okay, that looks pretty nice. And you can see it's way lighter at the top then. That's good. Now, we want this shading to change as our star rotates, right? So now in this case, we're going to want it to be lighter for those that are the faces that are in front, and darker for those that are in the back. Now, if our star is not, let's stop the rotation because it's really difficult to show it to you while it's moving. Okay, so while these faces are in front, we want them lighter than the ones that are in the back. So when the star is in this position, these faces that we see here in front, these are at their lightest. And those that are in the back, those are at their darkest. Now, note that for this arm at the top, we're not going to have both sides either lighter or darker. So one is going to be lighter and the other one is going to be darker. The one in front is going to be lighter, the one in the back is going to be darker. And the same if we have an arm at the bottom, which we may not have. This depends on the parity. So let me show you. Currently, we have 6 arms, so we have 1 arm at the bottom. But if we have 5, we don't have an arm down, right? And these 2 arms are one entirely on a single side. There's not another arm except the top one that's split between the 2 sides. So we need to see whether an arm is up at the top, like the top one, or it's down, the bottom one. So we need to create a test for that. So our test is going to be, so not up, right? It's going to be the minimum between 1 and the index I. And so if I is 0, this value is going to be 0. So it's not going to be not up, right? And if I is 1 or bigger, then this is going to give us 1. So this is going to give us 1 for all the arms that are not the arm at the top. So up is then going to be 1 minus not up. Okay, then we're going to compute a difference. This is going to be calc 2 times I minus n. And we could have used p here, so we could have used the p minus 0.5, but the thing is, we want this to be an integer so that it ends up working in browsers that don't support Houdini as well, because otherwise, yeah, we're going to need Houdini otherwise. So yeah, so not down is going to be, I don't know how to type, not down is going to be the minimum between 1 and the maximum. So this difference, which is basically this difference in absolute value, difference and calc minus 1 times the difference. So the thing is, let me show you that with the 6. So if you have 6 arms, this is going to have index 0, 1, 2, 3. So this one at the bottom is going to have index 3, which is precisely half of n, right? So this difference, 2 times 3 minus 6n, okay? This is going to give us 0. So for I equals 3 and n equals 6, this is going to give us 0. So this in absolute value is going to be 0 for the arm at the bottom, and it's going to be another value that's 1 or bigger for all the other arms. So not down, right? That's what we compute there. Now this is going to be calc 1 minus not down. So this up is going to be 1 for this one at the top, right? Not up is going to be 1 for all the arms that are not the one at the top. Down is going to be 1 for the arm that's there at the bottom pointing down, if there is one. So if the number of star arms is an even number. And it's going to be 0 in all other situations. So that's one thing. Now the next thing that we'll be doing here is compute a j value, right? So this j value is going to be, we're first going to have the case for the arm at the bottom, then we're going to have the case for the arm at the top, and then we're going to have the case for all the other arms. So we're going to have down times sine of k. Actually, this is going to be sine of j. We're not going to compute everything at once because it's just it would just get a too complicated computation. It's already going to be pretty long. So then we're going to have, oops, up times the sine of k, right? So these two have opposite signs. And then we're going to have not down times not up, okay, times, and this is going to be clamp minus 1, that difference, and 1, right? So what's it going to do? That difference is always an integer, right? Because this is an integer, right? And this is an integer. And it can be 0 for this arm right there, but it's not going to be because we're not going to be in that case. Or it can be bigger than 0, you know, and since it's an integer, it means at least 1, or smaller than 0. And again, since it's an integer, it means at most minus 1. So this is going to give us a value that's either 1 or minus 1. So it's going to put us one way or the other. So that's what it's going to do. And now we're going to get our j value, which is calc 0.5 times sine of j, and this j is going to determine our shading. Okay, plus 1, and that's it, we got our j. And we're going to have a shading progress custom property, which we'll be computing here. So this is going to be calc. So it's going to be 1 plus 1 minus j. So that's times minus 0.5. So that's basically going to be j minus 2, right? And actually you can just do that division, and it's just going to be 0.5j minus 1. Okay, that should do it, right? And then we're going to compute that shading here, and this is basically going to be minus 0.5j minus 0.25. So basically these lateral ones, you saw when the rotation is stopped, right? Come on, show it stopped. So when the rotation is stopped, this one is at 0% of the rotation. The ones in the back are at 50% of a full rotation. This lateral face pointing that way, the star-shaped face pointing to the right, that's at 25%. The star-shaped face pointing to the left is at 75%. So these two, this one is at 0, the one in the back 50%. So these are going to be multiples of 0.5, so 0 and 0.5. And these ones are going to be 25%, which is 0.25. And this one is going to be 75%, which is 0.75. So those are the values we want to get for that shading progress. Okay, so now here we can have a shading. So keyframes shade, and this is going to be 2, filter, brightness, and let's say this is going to be, I don't know, 0.2. So now here we'll have animation, shade, half of that animation duration, because it's going to be alternate, and let's say it's going to be ease in out, calc that shading progress times the animation duration, infinite, alternate, so something like this, I suppose. Oh, it's, sorry. Okay, something's really weird. No, that should have worked with just T. But apparently it's I feel very tempted to do something like this and just be done with it, because I must have computed something wrong somewhere. And I'll just do it like this. Because this pretty much does it. Yeah, I got something wrong. But, and I could probably simplify the computations and get rid of that minus 0.5. But for now, I'll just leave it like this. The video is pretty long already, and I won't be staying to figure that one out as well. So yeah, I hope you've enjoyed this video, and if you like the work that I'm putting out for more than 8 years now, please consider supporting it. You can do so by being a cool cat and becoming a patron on Patreon. The link is going to be in the description. Or you can get me something off my Amazon wishlist. Again, the links are going to be in the description. Or you can at least share this to show the world what can be done with CSS these days, because honestly, I think it's pretty damn cool. In any event, thanks for watching, and until next time. Bye!